Good morning, children. Let's review the two theorems in this lesson, circles. The first theorem, in a circle, radius is perpendicular to the tangent at the point of contact. And the second theorem is the length of tangent segments from an external point are equal. So now let's proceed with exercise 10.2. Both the theorems will be applied in this exercise question. First question, from a point Q, the length of the tangent to a circle is 24 centimeter. From a point Q, the length of the tangent to a circle is 24 centimeter. So let PQ represents the tangent 24 centimeter and the distance of Q from the center is 25. The distance of Q from the center is 25. It shows that OQ is equal to 25 centimeter. The radius of the circle has to be found out. That is, you have to find out what is the length of OP. This type of question is very important to mark question. So the given conditions are PQ is equal to 24 centimeter, OQ is equal to 25 centimeter, and what is to find is the length of OP. And now the first theorem, if you take, OP represents the radius, QP represents the tangent at the point of contact P. Therefore, you can take angle OPQ, or you can call it as angle 1. Angle 1 will be 90 degree. By the theorem, radius is perpendicular to the tangent at the point of contact. Immediately, triangle OPQ will become a right triangle and you can apply Pythagoras theorem. So, proof, angle 1 is equal to 90 degree. Radius is perpendicular to the tangent at the point of contact. Therefore, in triangle OPQ, OQ square is equal to OP square plus PQ square. The length of OQ is 25 square is equal to OP square plus 24 square. 625 is equal to OP square plus 576. That is, OP square is equal to 625 minus 576, which is equal to 49, or the length of OP is equal to 7 centimeter. The radius of the circle is 7 centimeter. Question number 2. In the figure, TP and TQ are two tangents to a circle with center O such that angle POQ is equal to 110 degree. Find the value of PTQ. It is given that PP and TQ are tangents for the circle with center O. Angle POQ is equal to 110 degree. You have to find out what is the value of angle PTQ. There are two methods of doing this question. The first type is proof. OP represents the radius, TP represents the tangent at the point of contact P. We can apply the first theorem, angle 1 is equal to 90 degree. Similarly, angle 2 is also 90 degree by the same reason. So, angle 1 is equal to angle 2 is equal to 90 degree. Reason, radius is perpendicular to the tangent at the point of contact. The first method is you can apply angle sum property in quadrilateral OPTQ. in quadrilateral OPTQ, 90 plus 110 plus 90 plus angle PTQ is equal to 360 degree. Angle sum property of a quadrilateral. So it is 90 plus 90 is 180, 180 plus 110 plus angle PTQ is equal to 360. 290 plus angle PTQ is equal to 360, or angle PTQ is equal to 360 minus 290, that is 70 degree. The angle is 70 degree. Or the second method is angle 1 is equal to angle 2 is equal to 90 degree. Therefore, angle 1 plus angle 2 is equal to 180 degree, which proves that OPTQ is a cyclic quadrilateral. What is the meaning of cyclic quadrilateral is OPTQ is a cyclic quadrilateral. What is a cyclic quadrilateral? A quadrilateral whose sum of opposite angle is 180 degree is termed as a cyclic quadrilateral. Or as a converse, if the sum of two angles of a quadrilateral, opposite angles, is 180 degree, then the quadrilateral is a cyclic quadrilateral, which shows that the other pair also is supplementary. Therefore, angle POQ plus angle PTQ is also 180, or angle PTQ is equal to 180 minus 110, it is 70 degree. By this method, you can imagine that there exists a circle which passes through the 4 points OPTQ. That is the meaning of cyclic quadrilateral. That means a quadrilateral whose 4 vertices lie on a circle, and at the same time in a cyclic quadrilateral the opposite angles are supplementary. Question 3. If tangents PA and PB from a point P to a circle with center O are inclined to each other at an angle of 80 degree, then find angle POA. The tangents PA and PB from a point P to a circle with center O. If the tangents PA and PB to the circle with center O are inclined to each other at an angle of 80 degree, find angle POA. Angle POA has to be found out. So, as construction, you can just write join OB. And now here, to get angle POA, we have to prove that these two triangles are congruent, from which you can get the two angles here as equal parts, and we can use angle sum property. How to prove triangle OAP congruent to triangle OBP is OA is the radius, PA is a tangent at A. Similarly, OB is the radius and PB is the tangent at B. Therefore, angle 1 is equal to angle 2 is equal to 90 degree. So, in triangle OAP and OBP, angle 1 is equal to angle 2 is equal to 90 degree. Radius is perpendicular to the tangent at the point of contact. Then OA is equal to OB, radius, and one more equal part is OP is equal to OP common. Therefore, triangle OAP is congruent to triangle OPP by right angle, hypotenuse, side by RHS. Therefore, angle 1, angle 3 is equal to angle 4 is equal to 40 degree, or you can read it as angle OPA. Now applying angle sum property in triangle OAP, angle 1 plus angle 3 plus angle AOP is equal to 180 degree. Angle 1 is 90, angle 3 is 40 plus angle AOP is equal to 180, or angle AOP is equal to 180 minus 130, which is equal to 50 degree. You can also prove the triangle OAP congruent to OBP by SSS congruence by PA is equal to PB, tangents from an external point, OA is equal to OB, radius, OP equal to OP, common. Therefore, the triangles are congruent by SSS criteria also. But angle 1 is equal to 90 degree, radius is perpendicular to the tangent at the point of contact, and apply that in angle sum property of triangle in triangle OAP. And now question number 4. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. The tangents drawn at the ends of the diameter of a circle. That means given a circle, let AB represents the diameter. The end points of the diameter are the points A and B. There are two tangents, one through A and one through the point B. We have to prove that those two tangents XY and PQ are parallel to each other. So what is to prove is XY parallel to PQ. And now the same first theorem, OA is a radius, XAY is a tangent at the point of contact A. Therefore, angle 1 is equal to 90 degree. Similarly, OB is the radius and PBY is a tangent at the point B. Therefore, angle 2 is also 90 degree by the same theorem. Proof: angle 1 is equal to angle 2 is equal to 90 degree. Radius is perpendicular to the tangent at the point of contact. But what type of angles are they? Angle 1 and angle 2 are a pair of alternate interior angles, and that alternate interior angles are equal, which shows that the lines are parallel by the converse of alternate interior angles theorem. But these are a pair of alternate interior angles for XY comma PQ. Therefore, XY parallel to PQ by converse of alternate interior angles theorem. Mark it as a very important 2-mark question. It's a frequently asked question. Question number 5. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Prove that the perpendicular at the point of contact to the tangent to a circle. So let's follow the instructions and draw the picture. Given a circle and a tangent XY at the point of contact P. Now, the question says that a perpendicular is drawn through the point of contact. The perpendicular is drawn through the point of contact, and we are supposed to prove that that perpendicular passes through the center of the circle. And now, as per the theorem, we know very well that the radius of a circle is perpendicular to the tangent. So, if we think the tangent at the point of contact P, and if a perpendicular is drawn through P, definitely OP in this picture will represent the radius, and the radius of the circle always passes through the center. XY is a tangent at P, and the perpendicular at P will be the radius of the circle, and the radius always passes through the center of the circle. Passes through the center of the circle. Question number 6. The length of a tangent from a point A at a distance of 5 centimeter from the center of the circle. We'll read that part once again. The length of the tangent from a point A, the length of a tangent from a point A, and what about that point A? That point A is at a distance of 5 centimeter from the center of the circle, is 4 centimeter. So, if you connect the sentence, the length of the tangent from A is given as 4 centimeter. You have to find out the radius of the circle. So now, as the previous question in this exercise, OP represents the radius, AP represents the tangent at the point of contact P. Therefore, angle 1 is equal to 90 degree. Radius is perpendicular to the tangent at the point of contact. Then, triangle OPA is a right triangle. In triangle OPA, OA represents the hypotenuse. OA square is equal to OP square plus AP square. 5 square is equal to OP square plus 4 square. 25 minus 16 is equal to OP square, or OP is equal to 9. OP square is equal to 9. OP is equal to 3 centimeter. Therefore, the radius of the circle is 3 centimeter. Question 7. Two concentric circles are of radii 5 centimeter and 3 centimeter. What do you mean by concentric circles? Circles who have the same center are called concentric circles. Two concentric circles are of radii 3 centimeter and 5 centimeter. Find the length of the chord of the larger circle at the same time it is touching the smaller circle. So, let the two circles, concentric circles, let the radius of the small circle be 3 centimeter and the radius of the bigger circle be 5 centimeter. We have to get the length of a chord BC of the larger circle, but BC is also a tangent to the small circle at the point of contact A. So now, if OA is a radius, BAC is a tangent for the smaller circle. So, in the smaller circle, OA is the radius, BAC is a tangent at A. Immediately angle 1 is equal to 90 degree by the first theorem. Radius is perpendicular to the tangent at the point of contact. Triangle OAB is a right triangle. Therefore, in triangle OAB, apply Pythagoras theorem as OB square is equal to OA square plus AB square. 5 square is equal to 3 square plus AB square. 25 minus 9 is equal to AB square. AB square is equal to 16, or the length of AB is equal to 4 centimeter. And now, if you join OC and proceed with the same method as in triangle OAC, the length of AC also you will be getting it as 4 and the total length of BC is 8. Or, if you have a circle with center O, if you have a chord, if a perpendicular is drawn from the center of the circle to the chord, the perpendicular always bisects the chord. Similarly here, OA is a perpendicular to the chord BC. If the length of AB is 4, immediately AC is also 4, which shows that the total length of BC is 8. So you can directly write it as, therefore, BC is equal to 8 centimeter, that is 2 into 4, because in a circle, a perpendicular from the center bisects the chord. Perpendicular from the center always bisects the chord. This question is also an important 2-mark question. Question number 8. A quadrilateral ABCD is drawn to circumscribe a circle as shown in the figure. Prove that AB plus CD is equal to AD plus BC. A quadrilateral ABCD is drawn to circumscribe a circle that is, all the sides act as tangents to the circle. That's the meaning of circumscribing a circle. The vertices are given as A, B, C, D, and the point of contact is P, Q, R, S. In such a figure, if such a figure is given to you, you will be asked to prove that some of the opposite sides are equal. That means what is to prove is AB, the sum of the opposite sides, AB plus CD will be equal to the sum of the other pair, AD plus BC. It's a very important 3-mark question, and the application of it also based on the numerical values. And now, if you look carefully into the figure, each side is acting as a tangent to the circle, as well as all the 4 vertices A, B, C, D are all external points. Take the first external point A, you can see the 2 tangents AP and AS. Similarly, with each vertex, there are 2 external tangents, and those external tangents are equal as per the theorem. The length of tangent segments from an external point are equal. Let's see how to prove this is AB plus CD. AB can be written as AP and BP. Similarly, CD can be written as CR and DR. That is, AP is same as AP plus BP and CD is the same as CR plus DR. If you can take tangents from the external point A, which corresponds with AP, AP is the same as AS. AP is equal to AS with the external point A. BP is equal to BQ. From the vertex C, CR is equal to CQ. And from the vertex D, DR is equal to DS. The reason, length of tangent segments from an external point are equal. Based on the second theorem, adding the left hand sides and adding the right hand sides, AP plus BP plus CR plus DR is the same as AS plus BQ plus CQ plus DS. AP plus BP is the same as AB. CR plus DR is the same as CD. You can bring AS plus DS together and BQ and CQ together. Just a rearrangement which shows that AS plus DS is giving you AD and BQ plus CQ is giving you BC. Thus, if a quadrilateral circumscribe a circle, the sum of the pairs of opposite sides will always be equal. This is a very important 3-mark question. Go through all these exercise questions thoroughly, as all of them are very important. We will do the next questions in the next class.